All right, everybody, and welcome to the Daily Space Weather. Congratulations on realizing that our channel exists. We've got new sunspots to talk about, as well as what kind of coronal mass ejections we forecast and which ones we don't. We'll break it down. Here's some new sunspots for you. This is 2843 down here in the lower right, the southwestern limb. That's a beta class sunspot. Here's sunspot 2842, and here's sunspot 2844. Behind it, well, maybe you can't see it, but I assure you there is another sunspot there. Anyway, let's talk about the coronal mass ejections that our channel forecasts. So viewing the sun from gravitational equilibrium point, Lagrangian point 5, we've got a spacecraft there. It's called Stereo A. And here's the recent view from Stereo A at Lagrange point 5, a massive coronal mass ejection. And frankly, we could have forecasted this one. We didn't forecast it because it's on the opposite side of the sun. So let me just draw in a quick little note here for you. We forecast coronal mass ejections only in this area. We don't do them on the far side of the sun. This area, we don't worry about this because Earth is in this direction. And so those are the coronal mass ejections we care about. Those are the only ones we forecast, and we've been doing it with 100% accuracy for several months now. By the way, there is a minor coronal mass ejection watch in place. I'm barely even going to touch on it. Again, Lagrange point 5 is where Stereo A is located. And this coronal mass ejection is not Earth-facing. That's why we didn't forecast it. However, there is a minor coronal mass ejection watch in place right now. There could be one unfolding as we make the video. I'm not particularly concerned about it. Let's move on to the solar magnetogram. So here's a colorized magnetogram of the closest star, El Sol. And this down here, this actually is a sunspot. There are umbrae there. And this area down here also. So the likelihood of solar flares has gone up a little bit. Again, minor Earth-facing coronal mass ejection watch in place. There is a filament up here which may be releasing at the moment. And that could indeed be the one that we're seeing on Stereo A also. Just keep in mind there is a bit of plasma between Earth and Sun, and it could eject in the next, I'll say, 12 to 24 hours. Anyway, this view is ionized helium. Let's take a look at some ionized iron ultraviolet emission spectra. This is 193 angstroms from the Solar Dynamics Observatory. Coronal hole rotating out, barely provided any significant high-speed coronal hole wind stream. And let's look at a diagram of the solar system. Here's where things are now. Let's advance it 1 week. And there's your astrography output for the next week, approaching another full moon here at the end of July. The 10.7 centimeter radial flux, still only at 72. We can expect to see this rise in the coming days. So here's the 1 year chart of the radial flux. This black line is the 10.7 centimeter radial flux, the most proportional data set to sunspot number when we look at solar activity. By the way, fascinating stories coming in our cosmology segment if you haven't checked that out. Cosmology segments are a playlist at youtube.com/smashamash/playlists. You can find all of our videos at youtube.com/smashamash/videos. 1 year chart here of the radial flux, sunspot number, and AP index is that blue line. We didn't see any geomagnetic unrest. The high-speed coronal hole wind stream was a dud. Let's talk about earthquakes and earthquake droughts. So we're looking at a chart here from 2018. And you notice this long earthquake drought right here, back in 2018. What did it end with? An 8 magnitude earthquake. You see that? That's like over 90 days there. 1, 2, 3, 4, 5. That's like 5.5 months of no 7 magnitude earthquakes. here's the current 90-day chart. Only one 7 magnitude earthquake over the past 90 days. In other words, have an earthquake plan. Know which buildings may collapse if you decide to evacuate yours. If there's an old building facade outside of your front door, realize that it may collapse if you're in an earthquake-prone zone. So, small uptick here in earthquakes, nothing in the 6 magnitude range over the past 24 hours. One of the largest of the past 24 was this 5.4 near the Loyalty Islands. There you go, near the Fiji-Tonga region there, north of New Zealand and Oceania. New Zealand saw a deep quake. Fiji saw a deep quake. And indeed, less than an hour later, Chile saw a deep quake, all the way on the other side of the Pacific Ocean there. Those quakes only about 42 minutes apart, both in the mid-4 magnitude range, the one by Fiji at 484 kilometers, the one at Chile, 193 kilometers. Anyway, just scrolling up the list here. If we leave anything out, leave us a comment. Let us know. We do read all comments, by the way, folks. And thanks to everybody who leaves comments. Taiwan saw a 5.2, as well as related aftershocks. Another deep quake struck South America there, a 4.9 at 125 kilometers. Another deep quake struck Tonga, a 5.1 at 126 kilometers. There was a 5.0 north of Ascension Island, off of the west coast of Africa. Nevada saw an extremely shallow couple of quakes here. 3 quakes, all showing up over 1,000 meters above sea level. All in the mid-2 range. And all occurring between 4:05 and 5:15 Universal Time. So some very shallow quakes. Let's take a quick look at those. And there is a location of one of those extremely shallow quakes. Again, that one's occurring at 2,000 meters above sea level. Anyway, continuing on the list here. And another deep quake at Chile. Let's look at volcanoes. Here's Karimsky. That eruption from July 9th on the Kamchatka Peninsula there. A very desolate location. And Karimsky is indeed on the list today. So it's been exploding and producing a 10,000-foot plume of volcanic ash. Suwanosejima in the Ryukyu Islands. 6,000-foot ash plume from it. Tall. Producing a bunch of volcano tectonic earthquakes. 185 of them. Sulfur dioxide emissions, and a nearly 5,000-foot plume of volcanic ash. Semeru on the Indonesian isle of East Java exploding, flight level 140. It's a 14,000-foot ash plume. Dakono exploding, 7,000-foot ash plume there. Nevado del Ruiz exploding, 19,000-foot ash plume produced by it. Revenador, volcanic ash not seen in satellite. Don't assume it's not erupting. Revenador, did I say? Sangay, not observed in satellite. Don't assume it's not erupting. Revenador exploding. Volcanic ash cloud to 14,000 feet. And Sabancaya still exploding in Peru, producing a 24,000-foot ash plume. And reminding us not to pole vault the caldera. Steve Stimpak used to pole vault calderas, and if you want to look up information about Steve Stimpak on the internet, well, you won't find it, because Steve Stimpak didn't want the kids trying to pole vault calderas. Anyway, this public service message of safety and security brought to you by smAshomash.com, where we tell you, please don't pole vault the caldera. And again, congratulations for finding that our channel exists. Next, the sun-facing suite of instruments on the GO 16. Here's the X-ray flux over the past 3 days. Only 2 B-class flares have occurred, and one of them was associated with that coronal mass ejection, we think. Anyway, here's the proton flux, and we do see a small spike here, as some of the ejecta may have actually reached the earthly region, but it's a very small signal, barely even relatable. Tiny uptick there in the GOES proton flux. Here's the GOES magnetometer over the past 3 days, and we're seeing pretty low highs and low lows over the past about 36 hours. We can expect to see this rise precipitously as the North Pole current sheet is just about to be in the Earth zone. So Earth is about to be in a new polarity current sheet. Here's a visualization of that. It's a top view ecliptic plane field plot. The top view ecliptic plane field plot. And you can see that green region there approaching the Earth's potential field surface source line shown in orange. That is the North Pole oriented current sheet. And Earth is in the process of snapping across now. If you want to watch it happen, the best place to do it is on the GOES magnetometer. Anyway, here's the line of sight data from the same data sets, the National Sunspot Observatory. And the data is from ground-based magnetometers as well as magnetometers on stereo A and B. Here's the coronal hole line of sight plot. And there is a North Pole-oriented coronal hole there, stretching down toward the equator. You can see that in green. This also shows the sun's B field. The blue potential field surface source lines are the B field of the sun. So here's another view of the new sunspots and the detected coronal holes imagery. This sunspot down here is the most likely one to produce significant solar flares. It's beta class, and as it approaches the limb, well, I'll just leave it at that. Sunspots are more likely to produce solar flares near the limb, especially major flares. It's not that big of a sunspot, but it does have opposite polarity umbrae, and they're significant. This one up here, not quite as significant. We'll show detailed imagery of that toward the end of the video. Global geomagnetism calm here. KP has only been at 1 over the past about 24 hours there. And let's take a look at the real-time solar wind, which is looking weak as well. Surprisingly weak high-speed coronal hole wind stream. So here we see the phi angle having recently shifted. Solar wind density just under 8 protons per cubic centimeter. Solar wind speed 328 kilometers per second. Very slow. It's been a very weak coronal hole wind stream. Most of it must have missed Earth. So here is the geospace magnetosphere movie for pressure. It should be 4 hours of data, and you can see quite a homogeneous pressure here, mainly on the magnetotail side, the non-sun-facing side of the Earth geospace. And this is showing 0 to 1.5 nanopascals magnetohydrodynamic pressure. And here are our ground magnetic perturbations. This is actually showing nanotesla, direct measurement of magnetic flux as it is on the ground. The last one is a little different data there. It's showing multiple Earth diameters. This is ground magnetic perturbations, geospace delta B, changes to Earth's B field, and we show it daily because of the geomagnetic excursion, which I'm not really scared of, particularly at all. So we just recorded an insane cosmology segment. It's full of crazy, important information, so check it out if you haven't. You can find it on the playlists, or you can find it on youtube.com/smashamash/videos. You'll find all of our videos on that URL. Let's talk about electrons surrounding the Earth. There aren't that many of them, not enough to cause charging hazards. Here's the 1-year chart of the earthly electron flux, and here is the 3-day chart. Nominal levels here. And here's the forecast model. The green boxes are the forecast. The yellow diamonds are the observation. Nothing to write home about there. And here's a diagram of Earth's Van Allen belts. Distances are shown in miles. And here is a visualization of the total electron content. And it's looking a little bit chaotic. Not anything like what we saw yesterday, though. As yesterday's total electron content was extraordinary enough to make it onto our thumbnail. So anyway, the belts of electrons here are a little bit chaotic. And this graphic shows you electron density for the whole air column, showing you where GPS errors are most likely to occur, which still is, by the way, around the equator at noontime. And next we're going to show you the F ionosphere layer located at about 300 kilometers of altitude. Just give that a minute to reload so we can see this slice of the atmosphere, the vibrational frequencies of the F ionosphere layer. And we're seeing anomalies here, once again in the northern hemisphere, over the North America portion of the planet. Right in this area, you'll see surprisingly high vibrational frequency zones, stretching all the way up to the North Pole, really. This area right in here. Anyway, let's bring up the latest image. Latest image coming through at 1900 Universal Time. Things looking a little more normal there. And by the way, we're also doing a meteorology segment today. Make sure you check that out if you haven't. We're going to start the video out with lightning. Here's a teaser for our meteorology segment as we continue on to show you bonus features. So the first bonus feature is going to be the El Teide ground-based solar observatory imagery here in hydrogen alpha, 62.8 angstroms. You can see some major filaments here between these two sunspots. And we're going to have 3 sunspot groups today. So the sunspot number is going to jump up, so is the radio flux. Here's some more data for you. But first, our patrons. Here's who our patrons are, at least the ones who want to be listed. Thanks, patrons, the true source of funding for the content, as we're paid just the sight of nothing to put the videos on YouTube. Patreon.com/smAsho if you want all kinds of perks and additional early alerts. Next, the thematic map from the GOES 16 SUVI. It's almost like cheating as it shows you all kinds of features. It shows you flaring, limb, quiet sun, coronal hole, prominence, filament, bright region, outer space, and unlabeled. That's if a Borg spacecraft should fly through the frame. We don't see any currently. Next, the high-resolution intensitygram. So this new group here is significant. Don't be surprised to see some significant solar flares out of this one. I believe that's going to be 2843, and up here we'll have 2844. Also beta class. So the likelihood of solar flares has gone up. There is a coronal mass ejection watch in the Earth-facing zone. It's for a minor coronal mass ejection. Here's the latest colorized magnetogram. We'll let it refresh here so you know we're showing you the latest imagery. Here's the field scenario for 2843, I think it'll be called. And here's the field scenario for 2842. Still only an alpha class sunspot. This one is a beta class sunspot. So we're going to have 2 beta class sunspots, and that is significant. And we'll close out the video here with 171 angstroms and colorized magnetogram. Thanks for tuning into Daily Space Weather. Again, don't forget to check our other videos. There are tons of them. YouTube.com/smashamash/videos. Congratulations on finding out our channel exists, and may that solar wind be at your back.